We were not. So Silvio is a very, I can say you are a very big name in your field, Silvio, and we were even unsure if we could even get him to talk at our webinar. We were very pleased when we dared to ask, and he was so polite and enthusiastic to participate. Silvio is a philosopher of science and is active in the field of science and technology studies. And at the moment, he's a guest researcher. After having been a professor too, now he's a guest researcher at the Center of the Study of the Sciences and the Humanities, SVT, at Bergen, University of Bergen in Norway. He has an impressively long and prominent career. And just to mention one thing, he is one of the two who introduced the concept of post-normal science, which is has been a very influential concept. He has written one of the articles that I can mention is the 93 article Science for the Post-Normal Age, which has been mostly used and cited, is the most cited paper in the journal so far. And today Silvio is going to talk to us about transdisciplinarity in post-normal science. Please, Silvio, the floor is yours.
Okay, I'm very sorry for this delay anyway, but I'm glad that we managed to find a solution. Now, I will try to be brief, just to introduce the subject, and then it would be nice to have a conversation with comments and questions, okay? As I say, I started, I was connected when Elena was talking, so, well, and I'm sorry if Ina Maria has introduced, but I couldn't hear it, but anyway. Now, what I want to talk today is about, science in the policy sphere, okay? And the idea, and I think COVID made it quite clear, about the importance of science and scientific inputs into to justify and to legitimize decisions and political action, okay? Now, and in that sense, this is true from national governments and also for international organizations and, for example, the European Union, but also WHO, now important because of the pandemics, and also IPCC, for example, for the climate. So the idea of evidence-based policy is quite diffuse. And I think you have heard about that, about evidence. This is not by chance, but it is what I established from the beginning of what we call the European modern state. And then it has been diffused all over the world, and as I say, in international organizations. So the idea that what I can call and describe as the problem-solving strategy of the modern state. The idea that you have a political, practical problem, you translate it into a techno-scientific problem, you solve the techno-scientific problem, and then the political and practical problem is also considered solved, okay? Now, in order to do that, you need to simplify complexity. So later we can talk about that, but I don't have time to go into details. So I have to apologize again for being a kind of schematic in the presentation. The idea you have to simplify complexity. But there are many different ways of simplifying complexity. And in order for this idea of that is this part of the European modern state, emergence of science, the idea goes into control, quantitative prediction, and rational management. And in that sense, you have to assure certainty and the truth. So in order to make it work, you have to have some assumptions. And the way I tell the story is that with two assumptions that I consider fundamental in order for this to work. The first one is to consider our bodies, our persons, an externality to the problem-solving strategy. And the second, to consider the context also an externality. In that way, this has some consequences. The first is you can talk about separation of facts and values, okay? It's a duality. And then you have science managing facts, and then you have our governance institutions managing values aspects, okay? The second consequence of the second assumption is that you can analyze a problem independently of its context and its relations, the boundary relations. Okay, so in that sense, with these two assumptions, what you have is this idea of value-free science, objective science, and the development of disciplines that deal with isolated components of the systems, which you can think that the relation with other parts of the system are just negligible, or you can ignore them. You know, for philosophers of science, that's you can remember Galileo's idea of primary and secondary qualities and all those type of things. Now, so with these two assumptions, then you can establish that you solve the problem. The problem is considered simple or complicated. Complicated is just to add simple problems, okay? And this is a way in which the modern state developed is, as I say, as a justification and legitimation of the political action and decision making. Now, it was a successful strategy in the sense that what you have is an incredible development of science, technology, and also of our governance institutions, okay? But when I say incredible development, of course, there is it's a bit of ambiguous, because at the same time, it enabled the colonial expansion of small European countries, okay? And today, this is a matter of discussion at universities, academia outside, and this idea what it means colonization and decolonization, right? So in a sense, it was incredibly successful. In others, had some consequences which we should think about it. Okay, now this works quite well, and I have to do now a kind of fast forward, and it worked quite well until the 1960s. In 1960s, what you had is beginning to question the idea of progress. Okay, the idea of progress, which is part of the development of the justification of in the modern state. For example, Condorcet invented the notion of progress, and if you read in his refutation of the Malthusian thesis, yes, he argues that the development of science and technology, the progress in science and technology, goes hand in hand with a moral progress. Okay, so for those people, creators of the modern state and modern science, it was for them it was evident that science and technology progress means also moral progress. Now, this idea starts to be, in a sense, questioned, and as I say again, I have to simplify, around the 60s. Philosophers of science, social scientists will remember that in 1962, Thomas Kuhn published his structure of scientific revolutions, where he questions the mainstream idea about progress in science. That year, 1962, was also we saw also the publication of another very important book, which was Rachel Carson's The Silent Spring, where Rachel Carson talks and gives a warning about the pathological consequences of applying technoscience in agriculture. No? I think most of you know the book and know the significance for the creation of the environmental movement. So you have Kuhn, Rachel Carson, starting to have an audience, have a public that is interested in reflecting about the ambiguities of progress. Okay, now in 1963, probably, I don't know if it's not so famous, this book is by Derek Price. It was called Little Science, Big Science, where Derek Price, studying the exponential growth of science, argues that this will create, and is creating already, a quality problem for science. You know, and you perhaps don't know the name, Derek Price, and the book, but you know about the consequences of Derek Price, because he's the father of scientometrics. And it is about the quantitative indicators for quality in science. And I know that every person in academia, you know, knows about, you know, H indices and impact factors and all the things. And, you know, it has benefits, but it's also big disadvantages, okay, that I think everybody knows. So what I'm saying is that during the 60s, it starts a debate and a discussion about the ambiguity of progress, technoscientific progress, the idea that not always, as it was assumed, science and technology, the progress of science, goes hand in hand with moral and personal progress. Now, during the 70s, this is also discussed and in relation to precisely this simple idea of evidence and the idea that you can strictly separate facts from values. But already for philosophers of science in the early 50s, there was an article by Rootman precisely in the Journal of Philosophy of Science, and it was precisely about that scientists, as scientists, have used value judgments. In another opportunity, we can talk about this important paper by Rootman. But coming back in the 70s, a nuclear physicist called Alwyn Weinberg, who was working in Oak Ridge National Laboratories, coined the term trans science. And the idea of trans science, I won't go into details, but it was very much discussed in Science and other journals. And it was related to the fact that Weinberg said a trans-scientific problem is one where you can express the problem scientifically, but you cannot solve it scientifically, okay? Until then, it was assumed that if you could, and look at what I call the problem-solving strategy. The idea, if you can express a problem scientifically, of course you can solve it scientifically. Weinberg, using certain examples precisely of policy-related research, his case was nuclear power and environmental and health effects. So he argues that there are problems that can be expressed scientifically, but cannot be solved scientifically. Here again, I have to ask you to reflect. What does it mean to solve a problem scientifically? In philosophers of science, we'll call that a part of the demarcation problem, right? Which we can talk about that in another opportunity or when we have more time. But in principle, it was established and discussed, and that there are problems that can, as I say, and mainly those are problems which we can call policy-related research, research that it is done in order to provide evidence for policy and action. Okay, now if this is clear, and I ran through, it was not a very fast during the 1980s, with Jerry Rabbits, we were working on uncertainty and quality in science for policy. Part of that history, the trajectory I told you about, and what we did was we identify a type of policy-related problems in which were not amenable to the reduction of complexity that was assumed in modern science and in the coevolution between science and governance institutions. And I think Rani today wrote a tweet, where she put what we call the mantra, the post-normal conditions. And those are that the facts are uncertain, that there is a plurality of values which usually are in conflict, that the stakes are potentially high, and that decisions are urgent. Well, I leave it to you to exemplify or illustrate these four conditions in the case of COVID, or in the case of climate, or in the case of biodiversity and collapse of ecosystems and all that. Of course, in the early 80s, we didn't know about COVID. We were not talking about climate still as we talk today and the other things, but there were other problems like development of nuclear power for civil use, other mega projects, etc., etc. Those were projects in which you could see what we call the post-normal conditions. Okay. Now, as I say, you can yourself think and illustrate those examples. Okay, we can talk about later. Substantially, so what do you do when you are in post-normal conditions and you cannot reduce the complexity in the ways it was assumed for the development of modern science and technology? So what we argued is that we shouldn't be focusing. Okay, I have to be careful. What we said is that we have to put in brackets ideas about truth, about the separation of facts and values, and things of that type. Now, it doesn't mean that these are not important problems, okay? I have to be very clear on this. These are very important, but as they say in the case of COVID, we don't have the luxury to wait until those problems are solved eventually, if they can be solved, okay? That's done. So what we have to do then, we argued that in those cases and under post-normal conditions, what we have to do is to focus on something we call quality, okay? Quality. Now, quality, again, I have to be quite simple in the definition, but it is what we call and what in total quality control in industrial and other cases, they call a fitness for purpose. Is how good is your input processes and products in relation to a purpose, a function, an objective, okay? Now, and in different from the idea of truth, which I won't go into, but you can think about Aristotle's definition, a definition about truth, about saying the truth. Quality is a relation, as I say, between a process and a product and a purpose, which has to be socially defined. And it is a result of a process of it's a social political process, that purpose. So, in those more normal cases, you have to evaluate that how good is your evidence in relation to a purpose which is socio-politically constructed. Okay? Now, this is important. And of course, it establishes a totally different relation between science and governance, or research and governance. Again, I have to be careful, and for the moment, and today, I'm talking about policy-related research. I'm not talking about quantum mechanics, okay? We can talk about in another opportunity. But now I'm talking about policy-related research. And what we argue that the operationalization of this quality evaluation is done by what we call an extended peer communities. Okay? And these extended peer communities will define what is the purpose, what is the problem, what is the framing of the practical political problem, and then they evaluate the quality. Okay? And because of its relation with complexity, then you can justify that you need a plurality of perspectives that are diverse and inclusive, because those perspectives cannot be reduced one to the other. So there is no overarching perspectives that contains all the others. So through the idea of quality in cases of post-normal conditions, through the extended peer communities, what you have is a process in which all these things are debated, deliberated. And perhaps you are aware about this work that is very much used, co-design and co-production, works of that type. Now, if it is clear, then what we have to do is to think about what are the consequences in terms of knowledge production, okay? And what are the consequences for our institutional settings, okay? For what we call the regime that emerged with the modern state. This has very important consequences. And these are institutional consequences. These are legal consequences. These have constitutional consequences. And also it has important consequences for the development of science. So in that sense, I will just give, because it's related to the term of disciplinary science, interdisciplinary, transdisciplinary, and so forth. I'm going to read only three corollaries, let me call them, of this assumption. Starting with the point that we have to we have to necessarily reduce complexity. But the question is, how do we reduce complexity without assuming that our bodies, our persons, and the context are not important? Okay? So I always said when I talked about this is that remember when we were young and we used to crash into parties without being invited, and usually we ruined the party also in the meantime. So the idea is that, well, our bodies, our persons, the context has invaded the context of research and production of knowledge. They didn't ask for permission. And therefore, the whole process, I don't know, perhaps you know Latour's book about the pasteurization of France, no? And the idea that Pasteur, the countryside in France, you know, agriculture became like an extension of Pasteur's laboratory. What we have, and we argued that in our 93 paper that Elena mentioned, is that what we have is the inverse process, that nature has invaded the laboratory. Okay, and therefore we have to cope with that situation, and then we have to think about what are the consequences, as I say, for science, for institutions, for our legal and constitutional arrangements. And this idea that in order to solve a problem, you have to find first the evidence, express it quantitatively, and therefore you can predict, you can manage rationally, and you can control. What we are saying is that this idea of control is futility. Have to abandon it. It doesn't mean that we cannot anticipate, but prediction is another story. Now, I was going to finish this part, so saying about three consequences, as I mentioned, of thinking about this in the way we argue with this idea of post-normal science. The first is that, as we have seen, that in the case of COVID or climate or other, as I say, problems of the same type, science doesn't speak with one voice. But I think the interesting development with COVID is that you saw experts in hard sciences, okay? Let's go mature scientists, not social sciences or, you know, arguing and expressing contradictory ideas and perspectives. Think about epidemiological modelers, things like that, you know, big discussions, and not always civil. Anticipating results of not very good quality. Very prestigious journals have to apologize and retract the papers. Okay, so one thing is that science doesn't speak with one voice, speaks many voices and not always expressing the same truth. Now we have witnessed that, so I don't have to go into details. The second element, as I mentioned, is that science is not the only form of legitimate knowledge. Okay, and think about it, that big challenges in our history, humanities history, were solved not by science, but by other types of knowledge. Okay, and I always give the example of longitude, okay? The establishment of longitude. that was solved, the problem. I don't want to go into details. If you want, I will. It was solved by a clockmaker from Yorkshire. It's a problem where people like Newton and Leibniz failed to solve it using science. So, and there are other examples which we can talk later. But what I'm saying is that at a certain point in the history and development of the coevolution between science and governance institutions and et cetera, knowing that was considered more important than knowing how. And in the process, and now it's quite clear, you lose this notion that science is also a craft. Okay, also a craft. And many problems, important problems, have been solved by craft people, by other type of knowledge, not scientific knowledge. Well, what do they say about COVID? What is the first thing they say? Okay, wash your hands. Wash your hands was an idea by a doctor called Semmelweis in Budapest hospital. So he saw that doctors and nurses were working with bodies, you know, in the morgue, and then they worked to where the pregnant women were expecting babies. So he said, oh, let's wash hands before going from one to the other. Everybody laughed at him. They thought he was crazy because he didn't conform to the ideas about the spread of disease of the time. So what I'm trying to say is that let's think that not only we have to recognize that science doesn't speak with one voice or even with a unique voice, but knowledge in the sense of Wittgenstein doesn't speak only in one language, that you have many forms of knowledge that are legitimate and not reducible to science in terms of complexity, and that are important if we are going to face the important challenges that we have. A second element has to do with the idea that when we abandon control and prediction, then we have to cope with the certainty of error and mistakes. Well, we are living through that with the COVID pandemics. Okay, so what we are faced is with the social experiments. Well, this word is a bit complicated and also ambiguous, so I have to be very careful. But when we are working in a situation of incomplete knowledge or even unknown unknowns, when there are conflicting values about what to do and how to frame the program, and we have to make decisions fast, then errors are going to happen and mistakes. So the problem is not that we are going to make errors and mistakes. The problem is how we go ahead with this type of experimentation without losing credibility and legitimacy. It becomes an institutional, a political and constitutional problem. Okay? Now, I went more than I wanted to talk, but I think I wanted to give you these elements, and I will be happy to answer questions. And again, I apologize for rushing and the problems that, you know, this is a problem. You don't know with these techno gadgets when they will you have a gremlin, and well, thank you again. Thank you for the question. Well, you know, we are here for the long run. It's not a 100-meter race, but a marathon is. And I understand that established ideas, institutions are difficult to change. The other element that you have to consider is that changing from the old regime to a new regime implies an important change in the power relations. Okay. Now, considering all that, I think there is a very important evolution. I think there's a very important evolution. I think that if you look at the literature or in conservation science, in biodiversity and others, you will see many ideas related to post-normal science. Okay, and as I say, we never argued that disciplinary science was not necessary, or that expertise was not necessary. So we never tried to go into establish fields that in which they continue to be useful. I mean, some people say, well, when they say about post-normal science, oh, we have to call a focus group in order to establish the laws of thermodynamics. That's nonsense. Okay, we never said that, we never argued. The other thing is, of course, in order to do and brain operation, you have to have some knowledge and expertise. Okay, not everybody should be able to do it. Or fly a jet, right? They're pilots, they have expertise. The only thing we said is that, of course, you go to have that operation, or you go into a plane because you trust the system. Okay, you trust that the pilot will not be drunk, or the the surgeon will know what he's doing, will be gone in many ways. So there is a system of quality assurance that implies that you can trust that certain people will have some specialties that will enable them to do their job, and we don't have to know all the details about that. So now what we have seen is that the discussion has evolved. Okay, now in the latest documents about science advice, post-normal science is mentioned. Okay, and had the example of Peter Gluckman, who was chief scientist in New Zealand, who really diffused the idea of post-normal science, arguing, like it was done during the times I mentioned in the 60s and 70s, that most of the problems of this type have post-normal features. Okay, and therefore you have to take some consequences. Okay, so the last element is about uncertainty, which started our work. And what we argue now, that I've been working in and on uncertainty for 40 years, and I see a big change. When we started to work 70s, uncertainty was not a problem. Uncertainty was something that was used by troublemakers like us, to introduce some critical ideas. But it was not considered a problem. It was a problem that was solved with mathematics of one type or another. Later, uncertainty was considered in relation to precisely legitimacy of action. Okay, and I'm talking in the 90s, Okay, and for example, the precautionary principle was introduced in order to legitimize action in the case of incomplete knowledge. Now, and later, and in relation, for example, to big pharma, agribusiness, and so on, we learned that lobbies and powerful players hire commissioned research in order to produce uncertainty. And this is related to the idea that if you create uncertainty, you fight regulation, right? So you cannot understand this if you don't understand what I said at the beginning about this relation between science and governance, the question of justification and legitimation, and the idea that science, through the reduction of complexity, precisely arrives to the truth, expressed quantitatively. Now, you know, in the case of climate, and as I say, tobacco industry, there are books like The Fabrication of Uncertainty, A Merchant of Doubts, that perhaps you know, and all those whose purpose is to report about the use of uncertainty in a strategic manner. The fact is that we have all learned how to play the uncertainty game. So uncertainty now and complexity and precisely what I'm saying has become politicized. And it becomes a political problem rather than a scientific problem. Well, as I said before, there is a lot invested in keeping the system as it is. And because to change it, as I say, implies a very important shift in power relations. Now, one has to think about, and I didn't have time, I will, if you call me another time, I can talk about what are the implications and what I mean by precisely by complexity, and why we cannot work with only one aspect of a complex problem, because the main definition of complexity is not nonlinearity, etc., but it is ambiguity. Okay, so so it is difficult because you have to change a certain type of culture. The culture, for example, you say, okay, I'm not an economist and therefore I cannot judge what an economist is doing. Or, of course, I am not a biologist and therefore, and when you get these teams doing some of what is called Mode 2 research or a specific research in relation to build something, the nuclear bomb, for example, you know, then you have people working, coming from different disciplines, and they have to work together, okay? And the cultural aspect is that, and that has to do with our ideas of extended peer communities, and the idea is, who are your peers? And the fact is that once you move away from disciplinary basic science, your community of peers is extended. Take, for example, the difference between a disciplinary scientist and a medical doctor and an engineer. And this is why the state has a different social contract for engineers and medical doctors than they have for a physicist or a biologist. Okay, so the idea is that there are other people who are judging your work. And not only that, you go for second and third opinions. Right? So, and that has to do with what is at stake and precisely the complexity expressed as uncertainty. Okay, so you recognize this, the social contract already recognizes that when you move away from disciplinary science and you're talking about more complex problem solving involving, as I say, involving high stakes, you won't have a unique answer, right? And therefore, you extend. Now, and what we argue is just an extension beyond that, you know, and you can look at the difference, for example, between the work of IPCC on climate and the work of IBES on biodiversity. You know, how in one case there are some privileged type of knowledge, scientific disciplinary in the IPCC, and how the IBS is trying to overcome that, trying to orchestrate how knowledge can be put to work together. You know, for those who've done philosophy of science, and with this I finish, I promise. Remember this idea of the Vienna Circle, Otto Neurath, the idea of orchestration of sciences. Okay, this idea goes back to the 30s in relation to practical political problems. But now we don't, because as I say, we go beyond this idea that knowledge is only science. So what we need is a kind of choreography of knowledges. And the problem then, trying to, you know, I'm not trying to avoid answering, but there are answers I don't have. Probably this is why I didn't write a very important book, because I don't know how to write the last chapter, telling how the problems will be solved. Because I don't know if they will be solved. So what I'm trying to say is the problem now for us is the how, not the what. And we have concentrated too much on the what, not on the how. And this is important. We don't know how to cope with conflict, totally polarized identities and knowledge systems that are probably incommensurable. So my answer would be, let's start with the job, and all your young people, PhD students, postdocs, and the rest, saying that this is a great time for you to be there, because it's all to be done, right? And I'm sorry it cannot be more precise, but I think important people like Stephen Toulmin in his Cosmopolis, when he says the time of the blueprints has ended. And so, as I say, in terms of experimentation, okay, let's try it. Let's try to think about the how. And then make the mistakes and try to correct them. And my feeling is that if we can establish a quality process, then we'll have some quality answers.